Inference about two means, independent samples. As always, here first we should see if do we have these two requirements. These samples are obtained by simple random sampling, or the data results from randomized experiment. Our sample sizes should be large, and that means both of these sample sizes should be greater than equal to 30 because of having two populations. We have two sample sizes, so one from each population. These sample values are independent, so independent of each other, and then we can start testing, starting with step 1. We should know if do we have two tail, left tail, right tail. So writing null alternative, for null we always have equal to between population means, but for alternative, depending on what we have, if it's two tail, we have is not equal to, if it's left tail is less than, if it's right tail is greater than. So mu1 is population mean for population 1, and mu2 is population mean for population 2. Step 2, we should know what is alpha, our level of significance. Step 3, test statistic. Here the output is Welch T. And that is equal to finding the differences between two sample means. So x bar 1 minus x bar 2 divided by square root of standard deviation squared divided by sample size for the first population, plus same thing for second population. We have standard deviation squared divided by sample size. We need to know what is degree of freedom. Because of having two sample size, we are going to have two degree of freedoms. But we have to use smaller degree of freedom. And then we can use that one to find p-value. Step 4, after finding t, we can find p-value. If we had to tell, p-value is the sum of the areas in tails. Here on left, what we have on right, we should add these two to find the answer for p-value, or we can find the answer for either left or right tail and then multiply by 2 to find p-value for two tail. If we had left tail, our p-value is the area to the left of t, and if it's right tail, our p-value is area to the right of t. After finding p-value, as always, compare that with alpha. If it was less than alpha, you have to reject null. And finally, based on what your answer was in step 5, here, step 6, state conclusion. Here, when it says smaller degree of freedom, for example, let's assume that for sample size, which is from this one, from population 1, we had 42, and N2, our sample size from second population, that was, for example, 51. We have to use a smaller sample size to find degree of freedom. Or we can say finding degree of freedom and then say which one is smaller. So use that one. Degree of freedom based on n equal to 42. Here we have 42 minus 1, it's 41. And on this part we have degree of freedom is n2 minus 1, so it's 51 minus 1 is 50. So which one is smaller? This is a smaller degree of freedom and we have to use this to find our answer. Example, researchers conducted randomized double-blind study to measure the effects of drug on patients. Here is we have 115 patients total. They divided these patients into two groups. Group 1, they received 5 to 20 milligrams per day of olanzapine. With group 2, we have 60 patients. They received placebo. The effectiveness of drug was measured, and here we have this table is given based on group 1 and group 2. Group 1 is experimental group and group 2 is control group. This is group 1. This is group 2. For group 1, we have sample size as 55, mean as 14.8, and standard deviation as 12.5. But for group 2, sample size is 60, mean is 8.1, and standard deviation is 12.7. Part A, is this observational study or design experiment? This is design experiment because we have treatment. So this is design experiment. Since the treatment was given. So here this is N1, this is X bar 1, this is standard deviation 1, and here is N2, X bar 2, standard deviation 2. Part B, what must be true regarding the populations? To use wedge t-test to compare the means. So we have to write all these three requirements. So all those should be true. The first one, we should have simple random sampling. So the samples are obtained by simple random sampling. Sample size should be large. Recall that whenever we didn't have large sample size, our population should be normally distributed. And finally, sample values should be independent. So sample values are independent of each other. Part C. Does the evidence suggest that the experimental group, which is group 1, experienced a larger mean improvement than the control group, which is group 2, at alpha equal to 0.01 level of significance? So this one is group 1, and here group 2. Starting to test. Step 1. We should know what is null and alternative. Null is mu1 equal to mu2. Mu1 is for group 1, mu2 is for group 2. Now here it says experimental group larger than what we have for control group. So mu1, which is for group 1, that is greater than mu2, which is for group 2. In step 2, alpha is given. It's 0.01. Step 3, test statistic. Finding t. X bar 1 minus x bar 2 divided by standard deviation squared over sample size. That is equal to, for group 1, over sample mean is 14.8, minus for group 2 we have 8.1, standard deviation 12.5 squared, divided by sample size 55, plus over standard deviation is 12.7 squared, divided by sample size. Using calculator to find the answer, we have to use parentheses. So if you're trying to enter all of these together, it's better to always use parentheses to make sure that your answer is correct. So on top parentheses, subtracting first, and then divide by square root. Here, it's better to use parentheses to make sure the answer is correct. Then, based on that, our final answer, I'm going to run to 3 decimal place. That should be 2.849. Now step 4. We have to find p-value. First, I should know what is degree of freedom. I have to use smaller degree of freedom. Here we have two sample size. One is 55, the other one is 60. So using smaller sample size to find degree of freedom. The degree of freedom is 55 minus 1 is 54. Writing both. So this is for the first group, and here degree of freedom based on our second group is 60 minus 1 is 59. And we have to use smaller degree of freedom. Now find p-value. Here we have right till So to find p-value, that is equal to I'm going to use this function from TI-84 TCDF. This is right till test. So first we have to enter our t as 2.849, comma, positive infinite. We can use 9,999 or 1 exponent 99, comma, degree of freedom. We have to use a smaller degree of freedom, which is 54. So I use second worst. This function TCDF, enter. And enter lower, upper. For lower we have over t is 2.849 and upper is 1 exponent 99 and degree of freedom is 54. Now enter. Here is our answer is 0.0031 running to 4 decimal place. I decided to run to 4 decimal place. You may have 3 decimal place, 5 decimal place, depending on what it's asking. But in this case, I just decided to run to 4 decimal places. The next step, compare our p-value with alpha, see if it's less than alpha. Our alpha is 0.01. So this is less than. That means we are going to reject no. Now finally, step 6, based on what we had in step 5, we rejected null. That means there is sufficient evidence. to conclude that, the improvement in the experimental group was greater than the control group. So we rejected null, meaning that we have alternative, and for alternative mu1 is greater than mu2. So this was our answer based on what we had for the degree of freedom. We tried to find the answer for degree of freedom by hand and use small degree of freedom. But if you're working on, for example, online assignment, you may have different answer for p-value, slightly different answer, because degree of freedom using technology is different than what we did by hand. As using this one, we're not using this, but if you're using TI-84, you're gonna see that degree of freedom is different from what we have here. I'm going to try that one. You can use that if you're working on online assignments to make sure that the answer is 100% correct. It's not different, because after running you may have slightly different answer. So for that part, the function that we can use on TI-84 is an exam. If your exam is on paper, just use these steps, exactly these steps, but you can use this one for online assignments, like homework or quizzes. And also to make sure that your answer for T is correct, you can double check. Using this function stat, so these are the steps you have to follow on TI-84 or TI-83. Stat, test, number 4, to sample t-test. So here we had 2 sample sizes and we had to find t. That's why we have 2 sample t-test. So press start. And then highlight test. So it's not edit, it's not calc, it's test. Then highlight number 4. Then enter all these sample size, sample mean, and standard deviation for both groups, group 1 and group 2. So here we have to use stat, is not data, but stat, and entered all these that I have here on this table. It's sample size, sample mean, standard deviation for first group, and do same thing for second group. And we have alternative as mu1 greater than mu2, so highlight that and then press enter, pull no, scroll down, highlight, calculate. And then enter. Here is what we have as t running to 3 decimal places, 2.849, which is exactly same as the answer that we had on the spot by hand. Our p is different, it's 0.0026 instead of 0.0031, so it's slightly different. Why? Because Here we have degree of freedom is 112.42 if we run to two decimal place, or to whole number is 112. But what we used was degree of freedom was 54. So by hand is what we did here. But using technology, our answer for p-value because of degree of freedom is different, slightly different. So depending on what you're working on, if you have exam on paper, just use this one. But if you have homework or quizzes online, you should have exact correct answer. If not, you're gonna have 0 on that part. You may receive 0 points because of having a slightly different answer. Just use stat test. But on exam, you can just use this one to make sure that your answer for T is correct. Construct confidence intervals regarding the difference of two independent means. We have two populations. So we have two population means and we have two sample means. For this reason, first you have to find the difference between these two. So subtract these two first, and then add and subtract margin of error to find lower bound and upper bound. So we need to know what is margin of error. That is equal to T multiplied by square root of, so this is critical value, T alpha over 2 multiplied by square root of standard deviation squared divided by sample size for both populations. So we have standard deviation 1 squared divided by sample size 1 plus standard deviation for the second group squared divided by sample size for second group. So to find T alpha over 2, that's using smaller degree of freedom. So here again we have this part, smaller degree of freedom. Or finding degree of freedom from this part. We didn't use that one, but we used smaller degree of freedom. Example. Researcher with the Department of Education followed a cohort of students who graduated from high school in 1992. He monitored the progress the students made toward completing a bachelor's degree. One aspect of his research was to determine whether students who first attended community college took longer to attain a bachelor's degree than those who immediately attended and remained at four-year institution. Here is what we have based on if we had transfer or not. So community college to transfer to four-year institution, and the second column is no transfer. I'm going to use this one as group 1 and this one group 2. The sample size for the first group, this is sample mean, and here is sample standard deviation. This is for second group. So first we should know what is null and alternative. Part 8, does the evidence suggest that community college transfer students take longer to attain bachelor's degree? Here our alpha is 0.01. So step 1. Null alternative population mean for first group that is equal to population mean for second group. There's one, mu1, it says community college transfer student take longer to attain. So this is greater than for the second group. So community college will transfer to 4-year institution that is greater than what we have for group 2, which is no transfer. Step 2, alpha is given is 0.01. Step 3, test statistic. So find the t, x bar 1 minus x bar 2 divided by square root of standard deviation square over sample size. So based on what is given on the table, we have x bar 1 is 5.43 minus x bar 2 4.43 divided by square root of standard deviation. We have 1.162 square divided by sample size 268 plus for second group we have 1.015 square over sample size 1145. Finding the answer using calculator, I round it to 3 decimal places and the answer is 12.977. Again, to make sure your answer is correct, use parentheses. Then step 4, find p-value. First, find the degree of freedom. Use smaller sample size. We have 268 and we have 1145. I'm going to use 268 to find the degree of freedom. So this is smaller degree of freedom, 267. Now find p-value. Here again we have right tail. I will use TCDF because of having the right tail. First we have to enter t. So it's greater than t. We have infinite degree of freedom. So here is what we have. Enter, and this is our answer. Our answer is not 1.73 because here we have this negative power is negative 30. So we have to use that one. Meaning that if using that one. Moving this decimal point to the left, we're going to have, running to 4 decimal place, we're going to have 0.0000. So first I'm going to write what exactly our answer was, 1.73. One 0, 41, 64. Exponent -3, so use that power. Run to 4 decimal place, it's 0.0000. That's step 5. Our p-value. See if this is less than alpha. Yes, so reject. Reject no. And final step 6, state conclusion. We reject it, so there is sufficient evidence. To conclude that, the mean time to graduate is higher for students that started in the community college than those who start at four-year university. So in this part, if you try to use stat test, you're going to have exactly the same answer for p-value because we run it to 4 decimal place and our answer was 0, and this is -30, and we may have a different power using TI-84. We may have, for example, -31 or -32 for this power. By using stat test number 4 to sample t-test and entering all these, again we have mu1 greater than mu2, exactly same as what they did on this part in this example. Here is what we have. So the answer for T running to 3 decimal place is exactly the same as 12.977. Our p-value comparing to what they had on TI-84 using TCDF, this was our answer for TCDF, but here we have 2.84 and here our power is -32. Because our degree of freedom here in this case is 368 using technology. And again, running to furthest home place, our p-value will be 0.0000. So running to furthest home place, again, same answer. Part B, construct 95% confidence interval for mu for the first group, which is community college, minus mu2, which is for second group, no transfer. So this is same as having mu1, 1 for the first group, minus mu2, 2 for second group. So instead of writing that, I'm going to write 1 and 2. We have to find x bar 1 minus x bar 2, find the difference first, and then add, subtract, e, margin of error. So this is what we need. First, we have to find alpha, which is 1 minus 95%, that is 5%, and alpha divided by 2. 5% divided by 2, that is 0.025. And then finding t, we have 0.025 over degree of freedom was based on which one is smaller. So it was 268 minus 1, 267. Then use inverse t, 1 minus 0.025, comma, degree of freedom. So inverse t, 0.975, comma, degree of freedom. Running to 3 decimal place, the answer is 1.969. Then after find t, we can find e. So first we did this one, now this part. E and t times square root of standard deviation square divided by sample size plus standard deviation square divided by sample size for the second group. Our t we wanted, and that was 1.969. Our standard deviation 1.162 squared divided by 268 plus 1.015 squared divided by sample size for second group. And run it, for example, to for the sample size, and that is 0.1517. in step 3. Now finding lower bound, upper bound. Find the difference between sample means, subtract E, so we have 5.43 minus 4.43 minus E 0.1517. I'm going to round to 3 decimal places, 0.848. And for upper bound, find the difference between sample means and then add margin of error. And answer is 1.152. This is our interval. Now interpret. We can be 95% confident. That the mean additional time to graduate for community college student is between these two numbers. .848 and 1.152. Do the results of parts A and B imply that community college courses causes you to take extra time to earn a bachelor's degree? The result that we had here was based on what was given in this table. May not be always true. So that was based on observational data. These cannot prove causation. But they can only prove association. Some reasons that you think might contribute to the extra time to graduate. I have this reason. So one of the reasons I may have. Community college students may be working more hours. So that's why they may not be able to take more units or additional classes. So community college students. Maybe working more hours. Which does not allow them to take additional classes. So this was all that we had for this section.